Okay, so next unit, we're going to begin by talking about measuring things. And so we are going to talk about something called the metric system. Now, whether or not you know a lot about the metric system, you have used it for sure, or you've seen it and encountered it. So the standard units of measure in the United States, we use what is now called the US system. It used to be called the English system because it was derived from the time of kings. The reason a foot is called a foot is because it was the measure of the king at the time's foot. So that was a measurement that changed, and different units were not really related to each other. So like an inch and a foot, they were just kind of haphazard. And so somewhere along the line of history, this started in France. I do not know the date, so I apologize. I'm not too much of a history buff. But what happened was the measurement system became more uniform. And so something called the metric system was invented. The strength of the metric system is that it is what's called a base 10 system for measuring physical quantities. And the reason that that's significant is because our whole number system is a base 10 system. Like when you see a number like 123, okay, this is my units place. And then each place that I go to the left is 10 times the previous place. Okay, at some point in middle school or elementary school, you were taught this. And if you plan to teach middle school or elementary school, you will teach this. So then this is the tens place. It's 10 times the units. This is the hundreds place. It's 10 times the tens place. It's called a base 10 system. And so the metric system lines up with that. And there's a bunch of good benefits for this. But the one we're going to focus on in this section, as we get familiar with the metric system, is that one of the benefits is being able to convert between different measurements. So as we get into the metric system, there's a base unit for different things you're trying to measure. So for instance, the base unit for length is called the meter. This room used to have one. I don't think I see one anymore. Used to have oh, here it is, right here. Sorry if you're watching on video, but you don't get to see this. This is a meter right here. And so you might be familiar with a yard. A yard is about 3 inches less. So this part that's not covered up with my hand. And in case you don't know what a yard is 3 feet. Okay, so a meter is just a little bit more. But no matter what, no matter when you are in history, a meter will always be this length, whereas something like a yard or a foot throughout history might not be always the same sort of thing. The base unit for mass is called the gram. A gram is a very small unit of measure. Your typical paper clip, okay, this happens to be a tiny one right here. This weighs about a gram. Okay, so a gram is not much. So if you're going to weigh like someone like me, you're going to need a larger unit of measure in order to do that and not have like several million grams. Okay, so we're going to talk about that. And then for volume, the base unit for volume is liters, which we're used to because we buy beverages when we go out. We're used to, if you've got a bottle of water, it's likely that that bottle of water is a half-liter bottle. Okay, that's kind of the standard for those little personal bottles of water. If you buy soda, you probably have bought soda in a 2-liter bottle. So it's two of the liters. So it's kind of the standard. And so the reason we're going into the metric system is some of you are going into the medical field. Everything in the medical field is going to be metric when you're dispensing drugs and things like that. Some of you are going to go, maybe you're going to go into construction or automotive. Stuff's in the metric system. So they're basically, everyone uses the metric system. It's just not the law of the land for us. Okay, so what we're going to do is we're just going to investigate just a little bitty bit of the metric system. We're going to kind of look at the everyday metric system. And so we're going to look at kind of the basic prefixes that you might see as you're living your daily life. Okay, so there are many other prefixes that represent things in the metric system. Depending on what you do, you might use bigger prefixes or smaller ones than we use, but we're just going to go into the basics. So here we go. The first one over on the left, and I'm doing these intentionally in order, and you'll see why. The first prefix is called the kilo. Okay. The prefix kilo, what it tells you is that you have 1,000 of something. So it means times 1,000, times 1,000. So if you have a kilogram, what you have is 1,000 grams. Okay, 1 kilogram means you have 1,000 grams. And now you're getting into kilograms is how you would weigh, or if you went to the doctor in a metric country, that's how you would get your weight, would be in kilograms. The abbreviation for kilo is just a K. All these are lowercase, although my writing makes that look uppercase, it's not. The next prefix is hecto. Hecto means times 100. So if you have a hectoliter of something, you have 100 liters. And the abbreviation for hecto is H. The next one's deca. Deca means times 10. So if you have a decameter, then that's 10 meters. Okay, you might, if you golfed in a European country, that might be the unit of measure you would use. Probably not yards, because that's what we would use. The abbreviation for deca is DA, not just D. D is used for another one of the prefixes. You'll see in just a minute. In the middle, we have our base, which I just introduced you to, the 3 bases. So I'm going to give you the abbreviations. The abbreviation for meter is M. The abbreviation for gram is G. And the abbreviation for liter is L. I'm going to write it as a cursive L so it doesn't look like an I or something like that. So all of the abbreviations should be fairly intuitive, except for deca. You just got to remember that that's DA. So these are all the ones that are big groups. You would use these in situations where you have something large that you need to measure. But now if you have something small, okay, so if you're in biology, or if you look on the back of your soda can, the amount of sugar that you have in soda or salt or anything is measured metrically using a smaller prefix. So for instance, deci. The prefix deci means times a tenth, so 1 part out of 10. So if you have a decimeter, okay, so again, here's my meter stick right here that you can see if you're live in class, okay, then this between my 2 fingers, from here to here, that's a decimeter, that's a tenth of a meter. Okay, so that might be the appropriate measure to use for something that you're measuring. The abbreviation for deci is just D. The next one is centi. So if you have centimeters, 2.5 centimeters roughly is about an inch. Okay, so if you know what an inch is, if you're used to that, 2.5 centimeters is about an inch. A centi is 100th, 1 part out of 100, and the abbreviation is C. And then the last one we are going to use here is milli. That is times 1,000th, or 1 part out of 1,000. So if you look on your soda and you see that your soda has 20 milligrams of sugar in it, okay, that is a thousandth of a gram. So the abbreviation is M. Now, again, like I said, there are other ones, like for instance, when you're dealing with computers, you're used to some other metric prefixes like mega and giga and tera. That's how you measure memory. Those are all metric prefixes. They mean times a million, times a billion, things like that. There's also going smaller. There's micro, which is a millionth, I think, and then pico, which is a billionth. So it just depends on what your application is. But if you learn the basics here, then you'll have no problem expanding your world depending on what application you have. So what we're going to talk about here is how to convert. Now, you do need to remember these prefixes. The way that I'm going to show you now, you may have learned this somewhere else. You may have lived somewhere where you're very familiar with the metric system. You might have to do this at all. But if you're just learning this, you do need to remember the prefixes. So there's a little acrostic. This is the one I remember. If you don't like this one, you can Google. There's other ones. There's one involving a cat and a dog, but I don't remember that one. But the one I remember is this. And this just helps you remember the leading letters so you can remember the order. So for instance, kilo, we'll say king, and then Henry died. So this is pretty morbid. By drinking chocolate milk. So if you need a little something to help you remember the order of the prefixes, there you go. So when you take the next test, and I'm going to have you do some metric conversions right off the bat, okay, I would recommend doing a quick brain dump of the metric prefixes. And when you do that, and I'm going to repeat this a bunch of times because it's really the only mistake students make doing this when it comes to the test. This is something students do really well. Don't forget the base. Okay, so the base, because we're going to be doing conversions just by counting along our prefixes right here. So my first problem that you can see says, let's convert 457.3 meters to kilometers. So rather than trying to give you some sort of rhyme, I know some teachers like to say when you're going from larger to smaller, do this, and have a rhyming word, and then from smaller to larger, do this. I'm not good with rhymes, but if that would work for you, look it up online, that'd be great. But what I'm gonna tell you to do is we're gonna start at meters, and we wanna go 2 kilometers. So here's the meters right here in the middle at my base. What do I have to do? How many hops and in which direction do I have to go to get the prefix kilo? You go 3 to the left, 1, 2, 3 hops to the left. So because of that, I'm gonna take the decimal. Because the metric system's base 10, converting is just this easy. I am now going to take this decimal and I'm going to move it 1, 2, 3 hops to the left. And so that means that my new number is 0.4573 kilometers. Now notice the thing that I am measuring has not changed length. What has changed is the units that I'm using. Okay, so for us, it would be like the difference between measuring something in inches and miles. Okay, it's going to be the same distance. It's just going to be a different number because you're using a different system of measure. All right, so the next one, we're going to change grams to centigrams. So again, grams is the base unit. It's right here in the middle. How many hops in which direction do I go to get to centi? 2 to the left, 1, 2. Now, the reason I gave this particular example is I don't see a decimal on this number 142. Where is the decimal assumed to be? Yeah, it's at the end right here after the 2. So the decimal is right there. So now I'm going to move the decimal place 2 to the right. So each time I move the decimal place, I'm going to add in a what, do you think, after the 2? Yep, so I get 14,200 centigrams. If you can understand those 2 examples, then that's pretty much what we're going to talk about from section 7.1. We're just going to practice it because I don't make any assumption that you've done this before. So I'm going to give you about 90 seconds, maybe 2 minutes to do the problems for exercise 1. Okay, so this is a great question. Also asked in my class yesterday. So in case you did not hear, the question was, what do I do if I need to convert milliliters to meters, right? I heard correctly? So you would not convert between those because they're measuring different things. So your meter is measuring length. And so then your liters is measuring the volume of something. So those are incompatible. So I can't make a conversion. Like if I have a 2-liter bottle of soda, I can't say how many millimeters is that. Okay. But really good question. So that we're processing this. Did I answer it? Great. All right, I'm going to get started. If you're still working, keep working. Then you can go through and check your answers. Remember, if you have a question at all, if you're getting a different number, if you're moving in a different direction, don't hesitate to ask that question. I want you to do amazing on this next test. And that means that you need to process this information. So the first one says, let's convert 0.98 liters to milliliters. So I'm at my base unit, my liters, and to get to milliliters, I'm going to go 1, 2, 3 units, 3 hops to the right. So that means I'm going to go 1, 2, 3 hops to the right. And for that third hop, I'm going to add on a 0. So I have 980 milliliters. Anybody get something different that we have to talk about there? All right, I'm going to keep going. I'm assuming that if you have a question, you would ask it because no one benefits if you don't ask the question. So the next one is 240 meters to kilometers. So meters is my base unit right here in the middle. So now I'm going to kilometers. So I'm going to go 3 to the left. So I'm going to take this decimal place after the 0 and go 1, 2, 3 to the left. So that's 0.240 or just 0.24. If you left the 0 off, that's fine. Kilometers. Again, did anybody get anything different? We doing okay? All right, next is 1.25 hectometers. So notice I've given this in the reverse order, so this is a slightly different problem. Okay, so if you goofed up on this one, that's okay. This one's just a little bit different. So this time I'm starting at hecto, and I'm going to meters. So now I'm going to move the decimal 1, 2 to the right. So I'm going to move 1, 2 to the right and get 125 meters. Did that one confound anybody? Okay, this is a pretty standard process. I'm hoping that you're being truthful with me because I would love to answer your question. The next one is deciliters to liters. So here's deci. I'm just moving it 1 hop to the left. So 1 hop to the left gives me 6.79 liters. And then last but not least, convert 142 decagrams to grams. So deca is right here. Going to grams, that is 1 hop to the right. So I have to add on 1 0 at the end. So 1,420 grams. Everybody still with me? Okay, great. Well, then the last example for me on this first page is it's basically the same thing. It's not really any more difficult. All we're going to do here is instead of converting to and from our base, in this one, we're converting 240 decaliters to kiloliters. Okay, so we're not involving the base in it at all. We're just converting between the prefixes. Well, if you could do the other one, though, you can do this. So deca is right here. What am I going to do to get the kilo? 2 places to the left. Perfect. So here we go. 2 places to the left. 1, 2. That's going to be 2.40. Make that decimal a little bit better. Kiloliters. All right. So please do the same thing on the next page. You might transcribe real quick. You might write your prefixes, see how good you do at remembering them. All right, again, I'm going to get started. So if you're still working, I'm not trying to rush you, just finish up at your own pace. So the first one, I'm going to convert centimeters to decameters. So here's my centi prefix. Don't forget your base when you're counting your hops. So I've got to go 1, 2, 3. Let me count again because I lost count. I'm starting at centi. I'm going to go 1, 2, 3 to the left to get to deca. So that is 1, 2, 3 to the left. So that's 0.0335 decameters. And we're off to the races. I'm just going to keep working problems. If you got a question, wave that hand in the air. If you have a question, definitely somebody else does. Maybe I'm making a mistake. Who knows? So this one, I'm going from kilometers down to decimeters. So here's kilo, my K, and I'm going to go 1, 2, 3. Don't forget the base, 4 to the right. So when I go 4 to the right, I've got to add 4 zeros onto this number. So it's 14 with 1, 2, 3, 4 zeros, decimeters. Okay, so 140,000 of them. The next one is 550 milliliters to deciliters. So here's milli down at the far right of my prefixes. So I'm going to convert that to deci. So I'm going to go 2 to the left. So I'm going to move this decimal 2 to the left, and I get 5.5 or 5.50 deciliters. Second to last one, I've got 0.345 hectograms. So here's hecto. I'm converting this to centi. So I go 1, 2, 3, 4 to the right. So that's 1, 2, 3, 4. I got to add 1 0. So 3, 4, 5, 0 centigrams. And then last but certainly not least, 0.5 deciliters. I'm converting that to milliliters. So I'm going 2 to the right. So that's 1, 2. That's going to be 50 milliliters. Did I do those too fast? Anybody got a question? Please don't let me leave this topic if you still have a question. Yeah, what's up? Because we went from, for B, the question is, how come 4 zeros? Because we went from kilo down to deci. So when I count, I'm just going to draw my hops here. I go 1 hop, 2 hops. Don't forget the base, hop 3, and then deci is the 4th hop. So I have to move the decimal place 4 places. No, the decimal place for 14, okay, it starts off as 14. The decimal is right here. When you don't see a decimal on a number, the decimal is to the right of the units. Okay, so there you go. No worries. Good question. Glad we cleared that up now and not on the test. So great. All right, so the last couple problems from this section, this is going to finish up, this page finishes up section 7.1. And so the next thing you're going to do, we'll do this, well, I think I'm going to let you do it. It's not super hard. This is just an exercise in applying and getting used to the fact that we're just using different measures, that when I ask you to list these from smallest to largest, you don't just right away look at the numbers and say, oh, 3.4 is the smallest, and then 104 is next. That's not necessarily true because each of these is a different unit of measure. So what you're going to do for this problem in exercise 3 is you're going to pick whatever unit you want and you're going to convert them all to the same. Now I'm going to pick just so that we're all going to do the same thing. But if you chose to do something different, I'm going to tell you to convert everything to meters. But if you chose decimeters or centimeters, you would come to the same conclusion. So convert each of those to meters and then determine which one's the smallest and list them. right, so I'm converting each of these to meters. The reason I picked meters is because it's also already one of the measures. So whatever you pick, I would recommend, because it'll save you a little bit of work, is pick one of the measures already listed instead of a brand new one. So 3.4, that's already in meters, so I don't have to do anything to that one. So the 3421 millimeters, I am going to move the decimal 3 to the left to make that in the meters. So 1, 2, 3. So that's 3.421 meters. And then the centimeters, I'm going to move 2 to the left. So that's 1, 2. That's 1.04 meters. Okay, so let's answer the question. Of the 3 original measures, which one turns out to be the smallest? Yeah, I'm going to write it as 104 centimeters, but if you wrote the 1.04 meters, that's fine. And the point that is trying to be made with this problem is that even though 104 originally was bigger than 3.4, because the units you were using to measure are different, that means that they are different things. So then the next one is going to be 3.4 meters. That's the middle one. And then the last one is 3,421 millimeters. All right, please do the same thing for exercise 4. We're just going to practice a couple more times because this was a fairly short section. If you want to do the same thing as I am doing, convert to meters. If you want to prove to yourself that you would get the same conclusion, even if you made them all kilometers, go for it. All right, I'm going to convert all these to meters. So converting hectometers to meters means I'm going to move the decimal 2 places to the right. So after the 4, when I go 2 to the right, that's 51,400 meters. The 62 kilometers, I'm going to move the decimal 3 places to the right. So 1, 2, 3, that becomes 62,000 meters. And then the last one is 680, and it's already meters. And so the answer to this one turns out that the smallest one was already the 680 meters. The next one is 514 hectometers. That's the next one. And then the 62 kilometers is the last one from smallest to largest. Anyone having any difficulty before we finish this last problem? All right, do the last one then, please. Exercise 5. Sure. Right, because the way we read our numbers, that number that's on the right when there's no decimal is our units place. So the decimal is assumed to be after that units place. So all the way at the right. So 514. So if you're writing things, if you're in like a science class, you could write 514 as 514.0. And 62 is 62.0. Those mean the same thing. And 680 is 680.0. Okay, so the decimal, when you don't see one, is assumed to be on the right. Any other time there's a decimal in the number, it will be written there. All right, I didn't say anything, but because I wanted you to pick whatever you wanted, I'm going to convert all of these to liters. So here we go. The first number, 4.3, is already liters. 420 is in centi, so I have to move that decimal 2 to the left. So that's going to go 1, 2, and be 4.20 liters. And then 0.045 kiloliters, I have to move the decimal 3 places. So 1, 2, 3, and that's 45 liters. So one final time, from smallest to largest, it turns out the 420 centiliters is the smallest of those measures. The next one is the 4.3 liters. That's the next smallest. And the largest of them is the 0.045 kiloliters. That's the largest of those units. So when you go to do your homework, that is what we are covering from section 7.1. Flip the page on your packet. We are just going to do one little thing. We're doing just a quick pop in for section 7.2. So that is what is on this last page. So if you need to remind yourself, just write a little 7.2 at the top of the page. And this is the only thing. So when you go to do your homework for 7.2 and the quiz, it's only covering this little blurb of information. So your intuition, though, your suspicion about what was asked earlier, how do I convert between meters and liters, was a good one, because we can use linear units to create volume. And we're going to talk about this in our 4th unit a little more. But for instance, if I want to find the volume of a box, okay, which is the only thing right now at this point in your lives that I assume you know how to find the volume of. So a box looks like this. You're getting my best middle school perspective when I draw right there. So that's lovely. And so when we have our box, we've got a width, we've got a length, we've got a height. Does anyone remember how to find the volume of a box? Okay, well, if you don't remember, it's okay. It's not super hard. All you do is you take those 3 dimensions, the length, the width, the height, and you multiply them. So the volume of a box is the length times the width times the height of the box. So we get the volume by multiplying those 3 linear measures. So what this table shows me is the conversion between my cubic meters of some sort and liters, because there's a relationship. So if you had a fish tank at home and you measured the length and the width and the height in centimeters, you would come up with a volume, and that volume would be in cubic centimeters. And then you might ask yourself, how many liters of water, how many 2-liter bottles do I have to dump into this? So you'd have to do a conversion. Okay, so that's what we're going to focus on here, is making this one little conversion. So I'm going to do example 3. This is a typical example. It's my favorite problem from this section. I will definitely put one of these on the test that you have next. So when you are, after you're done with your homework, when you're reviewing for the test, make sure that you review this problem here. You will definitely see it again. So here goes. Example 3. I've got a rectangular swimming pool. It's 18 meters long, it's 9 meters wide, and just to keep the example super simple, because we haven't talked about volume yet, it's going to have a uniform depth of 3 feet. So it's just a little, it's got the same depth the whole way. So what we're going to do first is we're going to find the volume of the pool in cubic meters. My length, my width, my height are all given in meters, so I'm going to find the volume. So here we go, the volume of the pool is equal to 18 meters, I'm just going to use M for meters, times 9 meters, times 3 meters, length times width times height. Then you can pop that into your calculator. When you pop that into your calculator, you're going to get 486, and here's what the units are. If I multiply 3 things together, if I multiply meters times meters times meters, what do I get? Perfect. I get meters cubed. And here's how I'm going to write it. This is the mathematical way to write it. I'm going to write meters with a little power of 3. That's cubic meters because it's a 3-dimensional quantity. Volume is 3-dimensional. If you prefer, If you don't like the mathematical way to write it, you can just write cubic meters. I really don't care either way. I promised you a minimum amount of algebra in this class. Okay, so that is the volume as a cubic linear unit, okay, three-dimensional linear unit. So what we want to do now is we want to turn this into our metric unit. So look at the table. If I have meters cubed, which I do in this problem, meters cubed are the same thing as what? I'm just going to draw an arrow right here. It's the same thing as a kiloliter, right? 1 cubic meter. So if I have a box, if I'm right in front of you and I've got a cardboard box that is 1 meter tall and 1 meter wide and then 1 meter deep, okay, if I have a box like that, I can put 1,000 liters in it. That's what a kiloliter is. I can put 1,000 liters. So that kind of gives you a vision for how big a cubic meter would be. So this second part of the problem, what's the volume in a liters related unit? Well, if it's 486 meters cubed, then it's 486 kiloliters. It's just a one-to-one correspondence. There's no calculation. You have to do it all. Then the last part of the problem just says, okay, now that we're in our base unit of liters, I can now do some conversions. So how many liters does the pool hold? So I'm going to turn kiloliters into liters, and you can write down your prefixes if you want. But when I go from kiloliters to my base, I go 3 hops to the right. So that means I have to add 3 zeros on the end of my number. So I have 486,000 liters. That's just the conversion using the prefixes that we did on the previous page. And that's really all I expect you to do from section 7.2, is just be able to use this table right here. So what I would like you to do, just so that you can get your feet wet, because that was just a pool example, that was unintentional humor, but I'm cracking myself up here. I want you to get your feet wet with exercise 6, okay? Do the same thing that I just did with that slightly different problem. All right, so I'm going to get started with this one. If you made any sort of mistakes, let's talk about them, because then I've just got one more. Since it's the only problem really that I like from this section, I have 3 of them on our little sheet here. Okay, so I've got a different box this time. It's 15 centimeters long, it's 12 centimeters wide, it's 20 centimeters tall. I've asked you to do the same 3 things. So the first one is, what's the volume of this in cubic centimeters? So the volume, you should have written down something like this. The volume is 15 centimeters times 12 centimeters times 20. By the way, if you have those 3 numbers in a different order, doesn't matter. So if you put the 12, 15, 20, or 20, 12, it doesn't matter what order you put them in. So when I multiply those 3 things together, what do I get? What's 15 times 12 times 20? Okay, thank you, 3,600. And then since I have centimeters times centimeters times centimeters, that is centimeters cubed. There's 3 dimensions of movement that I can make inside the box. All right, so now this is the part to the problem that involves this section. We've got centimeters cubed here. The second part to the problem says, what's the volume in a liters related unit? So I'm going to come up here. What is the unit that's related to centimeters cubed? Yep, I'm just going to draw the arrows so that you can see what I'm talking about. 1 centimeter cubed is the same thing as 1 milliliter. And by the way, just so that you can know how much a milliliter is, a 12-ounce can of soda is approximately 355 milliliters. Okay, the little conversion is right here on the side of it. Okay, so there's a lot of milliliters in this can of soda. So 1 centimeter cubed is equal to 1 milliliter. So I'm going to come down here. So that means 3,600 centimeters cubed is the same thing as 3,600 milliliters. And then I asked you to do the same thing on this problem. How many liters does the box hold? So now we're just practicing the conversions we did in the previous section. So to convert from milli to the base unit of liter, I move the decimal where? 3 to the left. Perfect. I appreciate your participation. So I'm going to move the decimal 1, 2, 3 to the left and get 3.6. You can leave the zeros off or you can write them. It doesn't matter. 3.6 liters. All right, one more, and then we'll be done with section 7.2. So if you would just do the same thing in exercise 7. All right, so I'm just going to get started. So the first one again says, what's the volume of the box? This time in cubic decimeters. So the volume is 12 decimeters times 8 decimeters times 5 decimeters. There's 3 dimensions in a box. And so 12 times 8 times 5, I believe, is 480. And then decimeters times decimeters times decimeters means I can go in 3 directions. So decimeters cubed. So then now I've got 400 decimeters cubed. What's the volume in a liters related unit? So I go up to the top. What liters related unit is related to decimeters cubed? Yep, I just thought I'd do one problem for each of the conversions on the table just to be a good professor. So 1 decimeter cubed is 1 liter. So I'm going to go back down here. So 480 decimeters cubed is 480 liters. And then I asked you to please convert that to centiliters. So to convert it to centiliters, to go from liter to centi, I move 2 to the right. So that means I have to add 2 zeros onto this. So I get 48,000 centiliters.